Hello, everyone, and welcome to the first episode of The Belinda Carr Show. We're going to be diving in deeper into building science, construction products, and technology. Today's episode, we're going to be discussing 3D printed concrete buildings. So a couple of months ago, I released a video on the lies and truths of 3D printed concrete houses, because there are a lot of misconceptions out there and false claims being made about this new technology. That YouTube video was pretty popular, and I'm glad it was, because over the last couple of months, I've seen a change in the language that these companies are using in their marketing campaigns. They're being a little more cautious with their claims. They're being more truthful, and I'm glad about that.
Do you think that's solely because of your video?
I don't know. That would be pretty obnoxious to think.
In your video, you talk about the lies and stuff and misconceptions in the 3D printing world. What is it doing good right now?
It's becoming a competitor to traditional construction. People are looking at alternative technologies, alternative raw materials that they can use, and one of them is concrete. And I feel like this 3D printing mania craze is coming at the right time for the industry. Like 2021, it just took off. It was the topic on everyone's minds in 2021, and I think it's just going to continue this year in 2022.
Because it's been around for a while. I know a couple of years ago you made a video, like an introduction to 3D printed concrete.
Yeah, that was in 2018. But what has really changed since then? I'm sure they've developed the nozzle heads and the motor mix that they use. They're constantly working on improving those.
The technology was in its infancy
back
then, and now they've had 4 years or 3 years to really do a lot of trial and error and see what works. And so hopefully from here on out, we'll start to see actual buildings built and all these claims that are being made that you've debunked start to come true. Because I hope you're wrong in a lot of these.
I do too, yeah. I absolutely do. I hope I wouldn't say solves homelessness, but I hope you can build homes much faster. And I hope it is a cheaper way of building. And I think it would be a better way of building than wood, because I've always talked about this coming from Dubai, where everyone used CMU blocks and concrete. That solidity in the structure is so different than in the States when you walk on wood floors, especially multi-story wood buildings, and the floors creak and the buildings move, and even in areas prone to severe weather, like California with all your forest fires or hurricane-prone regions, we've kind of just accepted that, okay, your house is going to burn down or your roof is going to blow away, and then you just rebuild. It's not really sustainable. Like building better, building a structure that lasts longer, that can save human lives, that's ultimately good for society. And I hope that switching to more durable materials like concrete, or a more sustainable version of concrete, hopefully, I think that would be better for the construction industry and for everyday people too.
I think a good example for that is when we went down to Austin and saw Icon's 3D printed house. It was a really windy day, and once you walked into the house, it was silent because of those massive walls. And I guess it's very similar to what we're dealing with today here in Texas or in Dallas. It's really windy outside, and we can actually hear the wind in this stick-built house.
You can hear the roof popping and creaking, and the doors move. And I mean, to a certain degree, that's going to happen when you have such strong winds. Even if you have a concrete house, your door is going to, there's going to be a lot of pressure on it. But the roof and the walls, hopefully those don't move.
Right now we have 3D printing is just walls right now. It's simply walls, not even load bearing, because they can't, but it doesn't abide by code to be load bearing. What's your prediction for when we see a full-blown 3D printed house, like roof and everything?
We need more problem solvers in the 3D printed world. Like we need the engineers, structural engineers and all, to be involved in the development of the machines, because they're the ones that are going to figure out how do you make a roof with a 3D printer.
Is it the developing the machines, or is it
Like tweaking the machines?
But could it also be getting more creative people, like more engineers and architects that, for example, well-known engineer firm Arup does some beautiful designs with their structure. And you don't think of that from engineers. You think that's the architect's job, is to come up with a beautiful design. The engineer will make it work. Well, Arup takes on both of those roles. So could it possibly be a matter of getting those engineers that are willing to experiment? I know 20 Additive Manufacturing does a lot of experimenting with their 3D printer, and seeing things like that makes it feel promising.
I think that's exactly what it is. I think architecture, construction companies, engineering companies, if 3D printing takes off, they're going to have to bring in material experts and people on the tech side into their in-house team so they can assist them. They can all work more collaboratively. Otherwise, there's still a big gap between what the designers are doing and what the software people or the technicians and the material scientists are doing. Because we're not going to figure out how to actually 3D print an entire structure unless we work together. Because everyone is in a highly specialized field. And they're an expert at what they're doing. But if you're a material scientist, you're not thinking about door frame connections to concrete. That's not your job. You're not trained in that way. But if you talk to a carpenter or someone in that sort of level of detail, they will help you figure that out. Or they will figure it out themselves and then give you a solution. So we need more communication between those fields.
It getting the publicity that it is now is good, because even if there are some false claims out there, hopefully that will bring more people into the industry, more people interested in this idea, and more people having to tackle those issues. You'll get more homes that are 3D printed, and then the carpenter comes in and says, well, what the heck am I supposed to do here? And they'll figure it out eventually.
And they'll come up with more creative solutions, and then hopefully they give more feedback to the 3D printing company. Like, next time you print this, do this instead, because it'll make my life easier and it will be incorporated better.
Which is exactly what happened with any form of construction.
Yeah.
I mean, stick built went through all this as well. So
it just happened so long ago. Thousands of years ago, we went around through those growing pains. So now we're seeing this emergence of a new, and it's exciting. That's absolutely exciting. It's a new way of building. We absolutely need that. We've been doing the same thing for so long.
A new way of building with a very old building material.
Yeah.
But that's one very nice thing about the 3D printing companies out there. They're really investigating new types of materials to use with their 3D printers.
Speaking of 3D printing companies that have invested in material research, I recently spoke to Black Buffalo 3D and had a pretty interesting conversation with them. So I hope you enjoy it.
Well, hello, Belinda. I'm Michael Woods. I'm the CEO and COO of Big Sun Holdings Group. And Big Sun Holdings Group has three main sub-operating companies. One is Black Buffalo 3D Corporation that we'll talk about today. One is Flash Labs Corporation, and the other one is Big Sun Modular. So it's a pleasure to be here today.
Thanks, Mike.
And I am Peter Cooperman, the head of marketing and strategy for Big Sun Holdings, reporting to Michael on those businesses.
And y'all are based in New York or New Jersey?
Well,
Both. Okay. So y'all have a factory in New Jersey, right?
yes.
We do. We have our headquarters right in Midtown on 28th between 5th and Madison. And then in Elizabeth, New Jersey, we lease a warehouse space that we've converted into a factory, which is just south of the Newark Airport, right off of the port of New Jersey.
Okay. So when did y'all acquire the building? When did y'all get started?
We incorporated the business in 2019. We adapted the business and expanded it in 2020. We took residence in our headquarters in 2020 spring. We took residence in the factory in 2020 fall, in September of that year.
Peter, we were talking a little bit about the people in your company and how they come from such diverse backgrounds. That they're engineers and designers, and so how did you all bring those people together?
I think we're in an innovative industry, so it just attracts the top tier talented people, no matter what you're doing. I know from a personal standpoint, I was attracted to Big Sun Holdings, and I've told Michael this many times before. I was reached out to by a headhunter, and I heard about blockchain, AI, 3D construction printing, everything, and I thought this is some kind of scam. there's there's no way a business has all this technology under one roof. And then I started investigating the parent company based in South Korea and all the sister companies that we work with, and we've kind of broken out from under over the past year and a half, but everything existed. So it's kind of, as a marketing and strategy guy, it's just great to be able to talk about stuff. And every time we mention a new business, someone goes, "You guys do that too? You do that too? Can I see it? Can I come to the factory? What are you doing with blockchain? What are you doing with NFTs? How high can you print?" And just questions like that. So I think as a process of attracting people the same way, and then within their network of our board members, of everyone involved with the company from day one, we've been lucky enough to get some leaders in very innovative fields to come work for us, from the material science side, from engineering, on mechanical design, and then of course on the technology side, not only who we employ but also who we partner with. And Michael will probably talk about that a little later.
Yeah, so it's very different than what I've seen in other startups, because as we know, the productivity in the construction industry is lagging far behind other fields. And I see all these people from the tech industry trying to disrupt it. But there's a big gap between their knowledge and the knowledge of people in the construction industry. So it's really beautiful to see y'all embrace that and say, okay, we're going to hire engineers, people in construction. We're going to use what knowledge you have, and we're going to blend it with the knowledge of people from the tech field. So I really appreciate that.
Thanks.
Yeah. So,
and don't forget the material side.
Yes, absolutely. That's
concrete,
a whole different field.
Yeah, it's an art.
Yes.
Right. And concrete is one of the hardest substances in the world to get right consistently. Right? You can get it right if you just add water and put ready mix together and throw it in a hole to stick up a flagpole, whatever. Right. Of course, it's going to harden. It's going to do its job. But when you're building to standards and codes, and you've got homes that have to withstand wind and fire and vapor and pressure, et cetera, that's not easy. Right? So the material side by far is the most important part of 3D construction printing.
That's very true. I think the printer that you have is the largest in the world, or the tallest in the world. But y'all are not focusing on actually building 3-story or 4-story homes, correct? Y'all are just going to be selling or renting these printers out.
That's correct. Our model's a little bit different than most of the other 3D printers. The main reason is, Belinda, we don't want to compete with our client. Our client is the builder. Our client is the developer. Our client's the government or a disaster recovery agency like a FEMA. What we want to do, our model is to build the technology, the best technology, the fastest, the most mobile technology, the best materials, so they can create a really strong, wonderful, long structures, and then also make it much more sustainable so that we're creating product that can actually help the environment while we're building different things, or our clients are building. So yes, we are a vertically integrated construction technology firm. That's what we do. We build the mechanical science, we build the robot, the machine, and we are currently the tallest, but honestly, let's be candid, it's technology. Somebody else is going to pass us and be 5 stories, 6 stories. We're going to get all upset. We're going to say, oh yeah, we'll go 7, we'll go 8, and someone will pass us. So this is just a short period of time that we happen to be the tallest. The main thing that we really want to do, we want to lead the material science development.
Have you actually built a 3-story or 4-story structure, either in the States or in Korea?
We have built walls that are that tall, but no, we are not the builder. We have proven the concept to be able to do it, but none of our clients have built that tall yet. I think there's one 3-story 3D building in Germany
Yes.
that's under development right now. That's the only one that's that tall, but it's coming. And the question is, can you do it? Absolutely. Have you done it? Yes, we have done it as a shell, but we would not finish that shell out. We wouldn't finish the interior, the outside, the foundation. That's for our clients to do.
Yeah, and I think it's important to also add to everything Michael said that, part of what we've been doing, a big part of what we've been doing for the last year and a half in material testing is one thing, but also just working with regulating bodies. It's public. We worked very closely with the ICCES on the AC 509 standard.
And the ICCES is?
The International Coding Commission.
Okay.
So they have the AC 509 standard for 3D printed walls. It's the only standard in the world right now. It was written for a single story. We worked very closely with them to rewrite that standard to make it multiple stories so that as part of our remit, we can, teach the trade and innovate and work closely with them so that, the first 3D printed building or 4-story printed building is with our technology into those standards. And, it was a big part of making sure that this is going to be viable technologies, standards and standardization throughout the world. So I think that's recognized. What is it, 53 countries, Michael?
55. And ICC is the largest regulator and creator of all of the residential, industrial, and commercial codes throughout the globe. And of course, in the United States, it's accepted in every state. And construction is all about standardization and coding. You can't have a one-off. If you have a one-off, then you have to get a special exemption from that municipality where you're building your project, which is really difficult to do. And that's where our industry has always been. This has been what everyone's been doing. And our partners and competitors out there, our frenemies, whatever we want to call each other, right? Our model is to grow the industry. Of course, it's going to benefit us. It's going to benefit all of our competitors as well. But if we don't standardize the industry, if we don't all work together to get this coding right, then
it's
no
just
one's going to accept
out.
3D.
Yeah.
That's right. It'll fizzle. Good point.
So y'all are building the gantry, building the footings, building the printer head itself too, the material as well. Y'all are developing that, and then y'all are just going to train other people, train other companies, and then sell this or rent this out to them.
Correct. We sell and lease the printers. We train our clients, the contractor, the GC, the sub contractor, et cetera, the developer that's doing it and working with a designer and an architect on, how can we use this concrete to make this look even better than just wood stick buildings, right? So we can get much more geometric shapes in all of the designs now, which is really great. And then the material science, we actually work with a company called MAPE, who's one of the the top 5 concrete and admixtures distributors and suppliers in the world. They are the ones who helped us with the AC 509 work to make sure that we got that right. And I got to tell you, that was one of the hardest things that we and our team has ever gone through. I don't wish this on anybody. It took us a good 10 plus months. It'll probably end up being about a year after all testing and results, et cetera, come back. It cost a lot of money to get done. And we broke a lot of things. We destroyed our printer. We blew up pumps. I can't tell you how many tubes we went through for that as well. But candidly, that's science. In science, you break things. You get frustrated because it takes longer. You got something wrong. The temperature changed on you, and all of a sudden your dynamics change. So the experience that we got over the last year of developing this material into something that doesn't stop the pump from gunking up. No one's been able to print more than 7 to 8 hours to pass AC 509. You've got to print, directly and continuously for about 14 hours. We do that now with this new material. Yeah. We don't have to stop, right? This is going to also dynamically change the industry, because now, instead of printing for 10 hours and your first shift is done, right, and you come back the next day and start over, no. You just keep on going, right? You just bring in another shift, and while that printer is moving along, the next shift comes in, the other shift comes out, and the printer doesn't need to rest, the pump doesn't need to stop. So the really the technical part of this business is enhancing tremendously. Not just us. So many other companies are doing similar enhancements that are really making this industry fantastic and hugely beneficial for residential, industrial, and infrastructure.
Yeah, like you said, there's a lot of exploration I'm seeing going on, not just in the gantry system. That seems to be pretty simple, but the nozzle head, like people are getting really creative with nozzle head designs. And but I'd like to talk about the ink, that the proprietary ink that you all produce. Every other company is basically using mortar. They're not using cement, they're not using concrete. It's basically 3D printed mortar houses. But y'all claim to use cement. And why is that? What is in the mix that makes it cement?
Well, we can't really tell you what's in it right now. It'll be public really soon.
But there's some sort of aggregates or something in it that give it additional properties.
It does.
Because it has a compressive strength of like 7,500 psi.
It cures at 7,500 minimum. I mean, we can dial that up at any time, right? So yes, and actually, when a wall's strength is weakest corner to corner, and when we had to do the compressive breakage, one of the rules or the tests of AC 509 is you have to actually break the wall. The lab on the East Coast couldn't find a machine strong enough to break our walls. They had to order one special, cost us an extra $20,000 for them to do this, and
to break a wall.
We were 3 times stronger than any machine that they could find.
Wow. And what was the need to develop such a strong material? Like, is it more expensive to develop something like this?
Well, that's a good question too. We're actually about a third less, per super sack, based on the competitive 3D material that's out there with other concrete companies that is non-coated. None of the material that's out there is coated in any way or standardized in any way. Ours will be and is, and we're also cheaper than them.
So even if you were to build affordable houses or one-story houses that do not need concrete that has a compressive strength of 7,500 psi, y'all would still use that just because?
Absolutely. There's no reason not to, right? It only makes the house stronger and better. It only, there's no reason not to use it. You're not going to get a material that's less expensive for less, compressive strength. So you would just use it as an example, approximate pricing, depending on where you are, because sourcing this material throughout the globe is going to be a little bit of a different price, right? But on average, to build a 1,000 square foot home, right, with a couple inside walls, that would take about 30 super sacks. Each super sack for us is probably going to cost about $300, right? So you're talking about $9,000 in material only to do the frame.
Okay.
That is stunningly inexpensive.
And I think we should even add to that. How many formulas did we go through, Michael?
60, 64, 65. I mean, there were so many different formulas. And as you asked, right, you have your aggregate, you've got your Portland, you've got different admixtures. You have to also have things for slump and shrinkage and everything else. And then we're testing it, right? And you have to allow concrete to cure for 7 days to 14 days to really see if it shrinks or it slumps or it cracks, etc. So we went through 60 plus different versions of this. And as I mentioned earlier, the frustration, of course, really starts to get you. But fortunately, we're working with some really good, competent, and smart scientists. Right? And the scientists are patient. Business operators, we don't even know how to spell that word, right? But our scientists are patient and they're understanding and they're methodical. And you know what? They did an amazing job. And what they have done, it's going to change the world.
So I saw on your website, I was looking at the raw material ingredients, and I saw oyster shells as one of the raw ingredients. I was very confused.
Yeah, that's an example of what we did in South Korea. South Korea has, of course, it's a peninsula, right? So South Korea has an overabundance of oyster shells. So many different concrete companies in South Korea actually crush up the oyster shells to be an aggregate within the powder. Okay. So you can actually use oyster shells as an additive in the concrete mixture to do 3D printing.
So would your mix be dependent on where it's made? So if oyster shells are not as easily available in the States and it doesn't make sense to ship it over here, if you're manufacturing the raw materials here, you would use something more local as a substitute?
Yes, correct. But we don't use oyster shells in our AC509 mixture. But if you wanted to use oyster shells, it's not load bearing, of course. So if you wanted to use to build a bench, to 3D print a bench or something cute and fun, you could do that. But for our main mixture, that will be a globally sourced and provided mixture, MAPE, our client or our partner, our distribution partner, they source all the materials. They will source it locally. As much as they can, and where they cannot get a part of our ingredients, then they will ship that in. But you can't really change dramatically the percentage and the ingredient mix when you have a standardized mixture. True. Right? Mm-hmm.
Yeah.
And really, one of my favorite things to show off at the factory, and I think you've seen it on videos, is our sample walls, where every 7 layers we switch up material. I am very happy I was not on the crew that was managing that.
Because the nozzle had to be cleaned out, and it's not just like, hey, just switch the mix and then print a couple more layers. There's an extensive cleaning process involved.
Right.
Yeah, I mean, we've been relatively quiet over the last year and a half while we've been doing a lot of work in the background, because that stuff just isn't sexy, doing every few lines. But now we're at the point where it's really great. We're able to have this conversation, and we'll be announcing a lot more over the next couple of months about projects with partners, our material specific. But you can actually see, just touring through our New Jersey factory with some of the sample walls we printed, different things that we've done throughout the last year and a half, the progression. And it's so obvious that even a layman can come in and they might point to, one wall and say, oh, that one looks great. It looks smooth. Why didn't you use that? And we'd say, oh, that's mostly mortar. That's why a lot of our competitors might look good. It's not structural, it's not functional, and it's expensive. Yes. So then you walk to other ones and, there might be cracks, and they'd say, oh, what happened here? And we go, well, that was number 42. We moved on from there. But it's been such a great journey to witness, and I'm going to be leaking out information. I like to go on a delay. One thing we're adamant about here is not to overpromise and underdeliver. Yeah. We want to make sure that all of our claims are backed up by science, as Michael talked about, that it's not just us running tests, it's also lab testing. I think we were the only company with our test printer basically outside in the elements in the East Coast of the United States.
Yeah, I saw your site wasn't tented. You weren't printing inside your factory. It was all outside. So all the research you've done and all your testing, it seems to have been done in stealth mode over the last year or two. And that seems to be a very intentional decision. Like, you all worked with the code compliance industries and all. Why is that? Why did you not share the process like other 3D printing companies have done?
There's a 2-part answer to that. One, we actually have tried to share. And the second one is, as Pete was saying before, our philosophy here is, let's not talk about what we're going to do as much as let's talk about what we did and where we are and how we can help. Right?
So instead of overpromising it, it's like, hey, we figured this out, it works, now we're ready to share it.
Exactly.
Right, because whenever you're building a new technology in the front end, it's just a lot of money, right? And so you're just pumping money into developing the product. And the product here is twofold. It's the robot and it's the material, right? Then it's also the process. How do you actually, flow this through, and how do you print and everything else? And that takes practice, and that takes time, and that takes building the expertise. So we didn't want to go early. We really wanted to get it right, because as big as this potentially can be, because as we all know, the construction industry is 14% of your global GDP, and it hires almost 9% of employable people. This is the largest industry in the world. And for the scale potential that this disruptive technology has for that big an industry, boy, you better get it right the first time, right? Of course, we're going to make mistakes. Of course, we're going to break things. Let's do it on our own, rather than going out there and then somebody seeing us break because we didn't do enough testing. So we've tested, and probably in a way, maybe we've over-tested, right?
Can we talk a little bit about Big Sun Holdings as a like a parent company? And I saw that you'll have a triangle diagram on your website, and the three parts of the triangle are smart Internet of Things systems, and you'll have a company called Flash Lab that deals with that side. You have smart construction, and then you have Black Buffalo that deals with that, and then you have the AI blockchain R&D lab. I'm fascinated with this approach because it's like 3D printing is, if you look at it from a large scale, 3D printing is a small part of the grand idea. There's so much more to it. And that's what really excites me, like bringing whether it's the NFTs or cryptocurrency, all this stuff to the construction industry, because it always seems like construction is a late adopter, and like the NFT market and cryptocurrency, it's an early stage right now, and everyone is still talking about it. It's still very unstable. People aren't sure what the future is, and you're already thinking about how to incorporate it in construction.
So you're right. We show it as a triangle because of our holding company and then the two sub-operating companies. And now we've got another one that I'll explain to you. So everything we do revolves around real estate, like you're saying. Our core business in our parent, as we talked about earlier, is we build large buildings. We do both the physical and the digital side. So in a way, what we've built here in the US as a global accelerator for our parent is we've built a virtuous circle. And a virtuous circle means that when you build another business and you have a core that you're really revolving around, we're revolving around real estate and technology, construction technology, digital technology, bringing it all to the real estate space, residential, commercial, industrial, and sustainably, right? So one business complements another. So when we're selling a printer into a large project of 200 homes or, a bridge or whatever it may be, we have our Flash Labs organization that works with IoT devices. It does data exchange of all of the data that's created by those IoT devices. We have an NFT minting platform that the NFT is actually the data carrier. It is the token for the smart contract that determines everything in that blockchain protocol. We're doing a big project with Black Buffalo. Flash Labs comes over and says, well, let's make sure that we protect all of the digital infrastructure in that project. So they get introduced to the digital side of that project manager or that developer to be able to help, right, to do both the physical and the digital. Then we also created a company called Big Sun Modular.
Yes. So
we're also the master licensee for multiple designs. The two of them right now are Kudu, COODO, which looks like a pill, and then a Codasima, which looks like a box, right? Two totally different designs, complementary to each other. And so we're the master licensee to bring those designs, both as prefabricated, but also as 3D printed models that will be able to fill different resorts, affordable housing. All of these are under $200,000 to be able to build all in. But remember, 3D printing can't do everything.
Exactly.
We're not going to 3D print every wall on the inside. Somebody's going to want a panel, right? An MGO panel or something different like that. We're not going to 3D print the stovetop, right? So, those type of areas, we do that through prefabrication. So again, a virtuous circle. We start to build a community. We're 3D printing with our partners, different houses and different prefab designs. Then the modular business comes in to be able to help with that. And as you build the modular home, Flash Labs comes in to be able to build the digital infrastructure of all of the blockchain and all the IoT devices and smart systems that go within that house. So it all works together in one big complementary circle.
So I have two questions now. First is that how much of this is hypothetical and how much of it is actually out there? Like when you talk about the IoT of things and Internet of Things and how you can create these smart homes. Do you all already have that technology? Is this something that you all are working towards right now? And when will it be available to the masses?
We didn't mention this, and I apologize for this gap. We're not the hardware. So we work with the hardware developers like Samsung and LG and Honeywell, et cetera. They're the ones that have the devices. We come in and we enhance and blockchain enable all of the different devices and connect them all together.
So y'all are the software. Y'all are just acquiring, like you all will recommend different devices from different companies and then link it together. Okay.
So you do a whole smart home package that goes into the home. And also the customer, again, can choose, I want a basic package, I want an advanced package, right? And just a difference in cost. And this is nothing, we're not doing anything really that much different than like a Simply Safe up in Boston. They do a great job. They sell these DIY, right, packages that you can put into your home. Great package. Home Depot does the same thing, right, with their private labels that they have in for DIY smart homes. So it's reality. It's happening. Has been happening for a while.
Yeah, and I think the differentiation is that we're finding ways to integrate the data captured from those devices to the blockchain. So any given day that you stop by the Black Buffalo factory, there might be a sensor on the printer getting ambient air temperature, weather, some kind of reading. And that's our Flash Labs guys experimenting with how much data they can grab, tie to the blockchain, and setting up that data capture so that 3 years from now, we have a really legitimate, verified on the blockchain data set of what the output was and what the conditions were. So we can improve the technology around the printing and the material as well. So like Michael said, it all ties around the virtuous circle. And it's really funny because anytime we hire someone new and we're expanding at Black Buffalo, they'll go, who's that guy walking around with a battery pack and a sensor and a bunch of wires hanging out? And that's someone from Flash Labs. That's hanging out testing something.
So related to that, to that's my second question. Do you all find at any point that you're spreading yourself too thin, that you all are taking on too much and there's something that you all need to drop off? And because you all are juggling a lot of new things, inventing a lot of new things and trying to figure out how everything comes together and works together.
Good question. Human beings remember mostly three things. Once you get past three, you get to 4 to 5, then you're just diluting, right? And everything is suffering. So we have 3 businesses, right? We have a 3D printing, we have a modular business, and then we have the technology overlay to those 2 core businesses, right? So we don't really feel at this point that we're doing too much. We have said no to other businesses in 2021 that our parent company asked us to focus on and build here in the US. So we're very aware that we can only do so much so quickly. And also when you've got a winner, and we've got a winner here with Black Buffalo, right? So, and the industry needs our help, and we need the industry's help to really grow this. So we've slowed down in terms of bringing more product and technology from Korea here. We're settled in now into our model with those 3 companies to really build this out for the near-term future. We're really excited about it. One other question or thing that you mentioned earlier was, the gantry, and one thing that we'd like to also do on that side, which is probably a little bit away, our gantries, our robots are called the next generation construction printer.
Next Gen 3, I think, is that it?
NextCon.
Sorry.
Yeah. So we labeled these 1G, 2G, 3G, et cetera, just like, first generation, second generation, et cetera. So think iPhone, you keep coming out with a new one, an enhanced one every couple of years. So what we're most excited about, like you were talking about the printer head and the nozzle and everything else, absolutely. We're all over that technology. What we'd really like to do in maybe this next generation partially, but definitely in 3G, we want to build Optimus Prime. We want that major transformer that comes out of the truck, transforms out, goes right over the site, starts printing, moves itself from the site with hydraulics and a handheld device, and moves to the next site and starts printing. That's the future of 3D construction, is mobility with the machine and the robot. Right now, most of all of us are gantries or a robot arm, and we're limited big time by mobility and speed of movement from one house to another, from one tilt up or precast job to another. So we're really going to focus on, obviously, our material science department is focusing on material, and then our mechanical is focusing on mobility and simplicity of the machine. And one other thing I'd really like to talk about, and I know Pete does as well, is, Belinda, you mentioned sustainability, how important it is for us to help the industry in terms of creating more sustainable and lower greenhouse gas emission materials. So we're really excited about hemp.
You all teamed up with Hemp Revive something?
We did. Right? We've teamed up with Jeff Whaling and the National Hemp Institute. Yeah. And we are creating, and we're already started this this project. We want to create, with so many partners help. You wouldn't believe how many people and companies and institutions want to be involved with this R&D. With all of our wonderful partners that we're working with, we'd love to create here in the near future, let's say within 2 years, we want to create the first hemp 3D printed material that is load bearing, that's AC 509 approved. Right? If that happens, let's talk about how that technology works. Technology works with hemp that if we're building a wall, we're building a bridge, a tunnel, a building, whatever it may be, that hempcrete, the science has been proven. The science proves that when you build a wall with hempcrete, because you're not using cement, you're using lime as your binding agent with hemp fibers, and of course all your other admixtures in that, that building, that structure, when it cures, it is breathing in CO2, sequestering it or storing it inside its own concrete for the life of that structure. That structure's a tree. It's breathing in CO2 the whole time that it's built, which basically means rather than emitting, right, your greenhouse gases, everything you build now is pulling it in and making the environment so much better. And for our building partners that are listening to this, when you use these type of technologies and this material that actually sustainably captures CO2, your carbon credit potential is incredible.
When I looked into hempcrete, it has carbon sequestration potential, but I didn't know it absorbs carbon dioxide from the atmosphere because it's a dead plant at that point and it's covered in lime. It has air purification potential or properties, but how would a dead plant in a wall be able to...
It's the chemical reaction in that material from the fiber and all the different materials from that hemp that makes it happen. We'll send you the third-party paper on the science. I totally agree with you. I didn't get it either, and I'm not a scientist. I still have a hard time saying, wait a minute, how exactly does that work? So I have to go back to this paper and reread it all the time. We'll send you the paper. Sure. You'll see it all.
Okay.
I do want to say, as a marketing guy as well, that we do have to rename it other than hempcrete.
Exactly, we can't call it hempcrete.
Because hempcrete, hempcrete is out there. Everyone knows it's not quite concrete. It's not, it's kind of a hybrid material. We want to do this in phases where we replace some of the percentages of our structural concrete that we have with sustainable material and work towards the fully sustainable material, so that we get to the point that Michael's talking about right now. But I think it'll be in phases. We'll see how much of traditional concrete type mix we can replace and make everything we do more sustainable by a certain percentage. as phase one. And that's basically where we're at now. We're extremely close to that. I think our technology also helps because there's so much less waste in the 3D construction printing process because you're not using forms, you're using software that tells you exactly how much to calculate. We've got it down to a science in our factory, even where when we're ending a print job for the day or we're just setting something up, we started buying molds so that we have no waste. Because cleanup, some of the videos online, we show the cleanup. We used 3 Rubbermaid garbage pails basically to do cleanup to get the excess concrete out of the hose. Yeah. At first, we were just using plastic bags and making stepping stones, I guess you could call them, and patios back to our offices. We've gotten a little more creative, but really the waste is so extremely reduced with 3D construction printing technology. And when you're doing design in CAD and different programs that are out there, it tells you exactly what you need.
So extract that information. If we're already building, we're designing our buildings in Revit and all that stuff, so we can extract all that information from it. That's it. Like, I come from an architecture background, and it always frustrated me to see how much information was lost between those stages, because you just print it out in 2D, send it off to the construction guys, and they're doing exactly what they did with AutoCAD drawings. They're not using any of that extra information.
Yep, and they're overestimating materials to make sure there's not an issue. If there's a supply shortage, they still get what they need. And, 3D printing just addresses so much of that and makes it easier. That the most important thing, in my opinion, besides the material that's going to happen this year, is just going to be a stepping up of companies like ours and our partner Allquist, of just putting curriculums out there, making the training and the technology accessible. And it's why we have an open door policy with our factory and our warehouse. And Michael even talked about the 3D Printing Association and how we tried to reach out to, other companies in the industry, and they would tell me I was crazy. And would you have us at our factory? And I'd go, yes, that's the point. Come whenever you want.
So if you're building a 3-story or a 4-story structure, have you all compared cost or time of just a simple precast panel that is already insulated? Like, it has a sandwich of EPS insulation. Like, it's a sandwich of EPS insulation. It's concrete, EPS, concrete. Cure on the ground, tilted up. It seems like such a simple way to quickly put up a 3 to 4 story building. And that's what everyone uses for Amazon factories and all these large structures now. But when we start talking about 3D printed concrete structures, like, does it really compare? Like, is it much better to actually 3D print such large structures? To me, the potential is in the design, or when we talk about actually like using geopolymers or using like hemp in the concrete. That's when I really get excited. That's when I see the next phase of it. But right now, when I just see mortar structures that print boxes, I don't see the future in it. Does that make sense?
Sure. It's a really good question. We haven't done all of the comparable yet to panels.
Yeah.
We're partnering with a company in Canada called MGO Systems, which does magnesium oxide panels. Exactly what you're talking about. With your insulation already fused in, your electronics fused in, the whole thing. Really great technology. And they want to do exactly what you're saying. Hey, how do we make this better with 3D? Is it possible? We don't know yet. What are the upside and the downside in terms of doing it or not doing it? So we don't have an answer to that yet, but we're like you, we're trying to think of, different areas that we can continue to enhance potentially or not. We don't know. And we're just trying to do it with partners rather than do it on our own.
So what are your plans for 2022? I saw that you all just bought a massive plot in Pennsylvania. What do you all plan on putting up over there?
We bought 106 acres, which is the East Stroudsburg Regional Airport. And we're closing down the airport, and we're building an mixed use industrial and residential area. We're going to 3D print as much as humanly possible. Up there, we're going to do a 3D park in the middle of it, because we'll have some quads for residential. So we'll have 2-story, 2 apartments top, 2 apartments on bottom, all 3D printed. Maybe we'll go up 3 stories, 4 stories. Let's see what the town allows us to do. We're going to do a prefabricated resort community because this is the Poconos, right? Wonderful ski area and summer hiking area in Pennsylvania. Then we will have our Black Buffalo factory. And we're really hopeful also that the Hemp National Institute for the Hemp Research and Development, their world headquarters, will be on our property as well. So we're really excited about this project. It was a really big and important investment for Black Buffalo, and we thank a lot of also the investors that came in to this business with us. We're going to put a lot of burnt rubber going from New York to Pennsylvania. It's a good hour and 10-minute drive from the George Washington Bridge, and we'll be going back and forth quite a bit, but it'll be worth it.
So I have this goal of one day building a house that is a gallery. Like you have so the walls are not just drywall, you actually see what's going on behind it. It's like it celebrates the building. It celebrates how it works. It celebrates how it comes together. So if y'all in your factory, if y'all could have like one precast panel right next to a 3D printed concrete panel and show people, hey, it took this much amount of material, it took this many man hours and this much time to build, versus a panel right next to it that was printed by a 3D printer, versus a panel after that had hemp incorporated in it. So that because you have all this land, you have so much potential. Like you could, your factory could actually be like a learning facility and actual proof that 3D printing is the future, and it has definite advantages over other forms of construction. That would
Belinda, you're gonna take my job.
Oh, okay.
You want to move out here and help us out?
That's exactly what we've been talking about internally. Also, we really want to make it a functional showroom. We don't want it just untouched and unused. I mean, to some extent, we will have wall panels and different examples, but we want to make it livable. We want to provide residents. We want to make sure that we create jobs in the area and people have affordable places to live. So we're going to be our use case. We'll see if we beat our customers to it. But we're going to be doing everything we can to stand that project up as quickly as possible and also be transparent about the whole entire process, because now we're out of the testing phase and we're really into the application phase, and it's going to be great. Not only for us, but for the industry. And we're hoping that, as we announce more about our materials and everything we've been working on, we're hoping that some people that might see themselves as competitors begin seeing us as partners or suppliers. And we really work closely because, as Michael said, it's the only way the industry is going to grow and scale at the speed that we all think it can.
Not just working independently, working together, not just like it seems like everyone's developing their own concrete mix, their own nozzle heads, their own gantries, and that's great. That's absolutely great. But at some point, everyone has to communicate.
Come together, just like any technology, right? You always have a spread out, and then it just kind of compacts in. And the best technologies or the most collaborative companies really survive at the end. The only thing on Pennsylvania, let's remember that we are so excited about that project. We always say, we're going to do this. We have 2 great building partners, right? So on the industrial side, our project manager and developer is Scannell Properties out of Indianapolis, who are just amazing, one of the largest ones in the country for industrial and commercial. They'll be doing the printing and the GCing and everything else. And then our partner, Alquist 3D. Will be helping us on the residential side, and that partnership has really blossomed with Zach Mannheimer. He's just they're doing amazing things and wonderful things for affordable housing throughout the U.S. And the Virginia property that they just rolled out, and the person took residence already as well, which is really cool. So we're really happy for our partners.
Thank you so much for sharing all that with me, and I'm excited to see what you'll learn in 2022, because I'm sure you learned a lot in the testing phase, but now when it comes to actual application and selling or renting out machines, it's a whole new learning curve associated with that side. So I'm excited to see what you'll do this year.
Thank you. Yes, we broke a lot in 2021, and we want to build a lot in 2022.
Yeah.
Yep.
Anyway, thanks a lot, Michael and Peter. I really appreciate it. Thanks.
Thank you,
It's our
Dylan.
pleasure. Thank you for having us.
So that was an informative interview with Black Buffalo. Belinda, what did you think about them?
Very interesting on several different aspects. Maybe not just the 3D printing side, but that grand idea of theirs of incorporating the blockchain and cryptocurrency and maybe the modular structures with 3D printed structures and smart IoT systems, all that stuff. That really interested me because I feel like it's all developing independently right now. And for a company like them to identify all those leading things that are the leading futuristic aspects of a home or a building and bring it together and work on integrating that, that really interests me. So I think they're going to learn a lot this year once they actually start building structures or helping people build structures and start selling this equipment, start using their proprietary mix and figuring out whether it really does work for 2-story or 3-story structures.
Yeah, they'll start to get that feedback from other companies as these buildings are being built. And then from there, they'll be able to tweak their machines and their gantry and all that to hopefully produce a better product. It's
a very different approach compared to other companies because other companies, as Black Buffalo claims, they have their motor mix isn't code compliant. That's what they said during the interview, other companies. But Black Buffalo purposely went through this stage last year where they developed this proprietary mix, made sure it was code compliant, spent $20,000 on a new machine trying to break their 7,500 PSI concrete. It's a very different approach rather than just go out there, test your printer and see if it works. I don't know about the 3-story structure. I don't. Let's just build 1 story first, see if the mix works, see how to put a freaking roof on your building, then go up to 2 stories. And code hasn't even caught up to that. Like in Texas, you're not allowed to build a 2-story 3D printed home. That's why those homes in Austin are 1 story, and then the second home is wood, stick built.
Right. It seems like it's always, with 3D printing, it's always an uphill battle with code right now.
Mm-hmm.
And I respect their approach of going to fix the code first. But then I also respect other companies' approach, like 20 Additive Manufacturing, that just does stuff. And I mean, really, coming from an architecture background, that's the only way to really learn. Like you can have all this prep beforehand, but at a certain point, you just have to start doing stuff. And hopefully in 2022, they start doing stuff like this facility in Pennsylvania they're going to build. I'm sure they'll learn a lot from it.
So what do you think about their new age hempcrete claims?
We can't use the word hempcrete.
We can't use the word hempcrete, but they haven't invented a new word yet. So I looked into hempcrete and all the claims being made about the wall sucking in carbon dioxide during its whole life, and it doesn't do that.
Wait, the hempcrete itself is a product that claims that it sequesters CO2?
There are scientists out there that you have to read the language very, very carefully, because what they are trying to say in their language, I can read it out to you if you'd like.
Absolutely.
The founder of the U.S. Hemp Building Association said this: "While we're growing hemp and building hempcrete, it's sucking in CO2 the whole time and encapsulating the CO2 into the structure."
Is that true?
That is true. But you can't spin that by saying that your hempcrete wall is going to be sucking in CO2. What he is saying that a hemp plant, while it is growing, it sucks in CO2 during photosynthesis. Plants need oxygen. They're not just sucking in CO2 during their whole life. I mean, people have this misconception that plants just don't need oxygen at all. Just all they're doing during their whole life is just sucking in CO2 and releasing oxygen into the atmosphere. No. During photosynthesis, hemp plants, like any other plants and any other trees, they suck in CO2 and then release oxygen into the atmosphere. And what they're trying to say is that they chop up the hemp plant and encapsulate it in lime so that it cannot decompose. With any other plant, when it decomposes, it releases all that carbon dioxide back into the atmosphere. It's net zero. It doesn't just magically disappear into nothing. So with the hemp plant, Once it dies, once it's cut up and and encapsulated into a ball, then that carbon dioxide is held in and not released. That's the advantage of hempcrete.
So that is a good thing.
Absolutely. It is a good thing. But it's not sucking in
continuously pulling CO2 in.
Yeah,
throughout.
Because that doesn't make sense. It's a dead plant.
There is some good to that statement. It's not completely untrue, but it just has to be worded carefully to where people know that you're not going to be pulling CO2 out of the environment in your 3D printed house.
But you're preventing it from being released into the atmosphere, which is good. I'm a big supporter of hemp. I think it's great. It's another competitor to traditional materials out there.
If there's one good thing that comes out of this 3D printing technology, it's the exploration of new materials. It's really exciting to see all these companies push so hard because concrete's been around forever. Like, where are these companies that are looking for new ways to just make CMU blocks?
It always comes back to cost. Like, over the last 100,000 years, people have always had ideas to build better or to come up with tweaks in their concrete, tweak in their concrete mix, and use pozzolans and geopolymers and all that stuff that people talk about. But it's all, eventually, at the end of the day, the cheapest thing is going to survive. If it's just too expensive, cost prohibitive to scale up, it's going to die.
That's called Darwinism.
But I think with wood becoming more expensive and people realizing the carbon footprint of concrete and all that, I think there's a greater demand for better materials. There's more buzz around sustainable materials. And I hope hempcrete, or this new age hemp concrete 3D printed mix, works out. It's going to be interesting because hemp in itself has no structural materials, and then they have this concrete mix with a 7,500 psi. So if they mix it in somehow and not reduce its compressive strength, maybe it can work and it can be a structural material. All right, so thanks for joining us on this first episode of 3D printed concrete structures. Let us know what you think about this episode and what else you'd like us to explore. Join us next week for another episode on building science, products, and technology. See ya.